Yeah, so in this program I'm checking for Fermat's last theorem, which states that a to the power n plus b to the power n can never be equal to c to the power n, where abc represents whole numbers and n represents greater than 2, any number which is greater than 2. But what I can't understand is that does n only pertain to whole numbers or not? And in this program I have taken abc to be 3 consecutive numbers. So it starts from 1 2 3 and then 2 3 4, like that, it goes like that. And since it is given 10, so it will be 10 11 12 the last time. So, and I've given the power value to be the last value of the power to be 10. Okay, so the last the last thing would be 10 to the power 10 plus 11 to the power 10 is equal to 12 to the power n or 12 to the power 10 or not. So let's check it. Let's compile it first, and it says no syntax errors, so let's close it and let's compile this also and let's check it. Okay, so it says that Fermat was correct for 3 4 5 6 7 8 9 10. Okay, so let me now change the values. Let me take it to be 100, and that still remains 10 because I'm checking for the same thing. So let's compile and let's compile again and let's do it again, and it says that he was still correct for all these values, right? He was still correct for all these values. Okay, so I'm so desperate. Okay, let me do it 1000 now. Let's check what happens. The computer is going to hang probably. I don't know. Let's see. Fermat was wrong. Okay, so Fermat was wrong for n equals 954 when first number equals 2. Okay, so let me now check this up. We can clearly see from here that if you do this thing, then yeah, so once I compile it, no syntax errors, so close it and then go to it, and it will show you false because it is not actually. And if you do it greater than that, it will show you true, but actually it cannot compute it. So it's just showing you infinite value or garbage value, I don't know what, but it doesn't work. So it shows you true, but it's not actually true because I've verified it from somewhere else. Alright then, Fermat, you tricked me, you bastard. Alright, you know what, this time let's not change the value of n, but let's change the value of these guys. So it was 10, so let me make it 100 and check what happens, right? So the last thing to be checked would be 100 to the power 10 plus 101 to the power 10 is equal to 102 to the power 10 or not, right? So I think it would provide me with a lot of results. So let's see what happens. So it says compiled, no syntax errors, and then let's do it there. Okay, so Fermat was correct. As you can see, Fermat was correct for these guys. So let's now change it again. Let's go it and make it 1000. Okay, so just a second. Okay, so it again says the Fermat was correct for all of these values. Okay, let's make it 10,000 now. Let's see what happens now, eh? Alright, so let's compile it and then okay, so it took some time to come here. I mean, it was like, you saw it, right? You saw it. Okay, yeah, it took some time, but still it shows that everything is correct. So it's computing and we can get that was computed. So now we've taken how much have we taken actually? 100,000. Let's take 100,000. Alright, so let's see it. Yeah, you saw that wave it came. So my computer is getting filled with junk files now. I mean, memory is getting blocked. Okay, So it's 1000 now. I don't know how to pronounce it. Shit. Okay, I think Fermat was correct. Okay, let's do it. I don't know what will happen now. It's gone. It's gone big time. It's gone big time. Let's wait for it, huh? Let's wait for it. This is huge. Oh my god, it will hang now. 8, 9, and 10. Okay, man.